So we stopped last time down here talking about how to combine conditions and make sense, right? And if this thing is true and this thing is true, then do something, otherwise do something else, or maybe nothing at all. The truth table for and is kind of self-explanatory, like it's only the and of two things is true if both things are true, like if that's true and the other thing is true, if it's positive and it's even, okay? So that's not too bad, I hope. Let us come back with that idea and give a little example. So here's my silly example. Let's make a program to calculate whether or not we should bring an umbrella today. It would be very nice if it was cold and rainy, but sadly it's just very hot right now. Let's pretend though. Let's make a program for when it becomes actually the fall or the winter. Okay? So let's make a program that calculates whether or not we should bring an umbrella today. Okay? We will ask the user, hey, is it cloudy today? We'll store that result. We'll ask the user, hey, is there a chance of rain today? We'll store that result. And I think if both are true, right? If both of these things are true, then we should probably say, yeah, you should bring an umbrella, right? Otherwise, I think you're all right to not bring one. So that's my silly little example. And of course, to combine these conditions, if this is true and this is true, bring an umbrella, we're going to use and. So if it's cloudy and there's a chance of rain, please bring an umbrella. Okay? So that'll be my first silly little program. Let me connect to my terminal and write it for you. When it decides to open, you can do it. Slowly but surely. Lecture 5 today, I think. Alright, Vim umbrella.cpp. So we'll ask the user, hey, is it cloudy today? Question mark, and they can type yes or no, maybe, something like that. We'll also ask them, is there a chance of rain? That's probably the most important question. But maybe if there's a chance of rain, but it's not cloudy, like maybe the weather people got it wrong. So that's why we're combining our conditions. Okay, so we want both of these from the user. They'll type yes or no. So let's get them inside of strings. String cloudy and chance of rain, let's call it. And so we'll get both of those. Cn cloudy, Cn chance of rain, and we're off. So the idea is if it's cloudy and there's a chance of rain, let's tell the user to bring an umbrella. Otherwise, they don't have to. So if cloudy is yes, is equal to yes, and chance of rain is also equal to yes, right? Those are two conditions. If this is true and also this is true, then we'll run the body of the if, the true branch. We'll see out, bring an umbrella. Yay. Otherwise, if these are typed no to any of those, I think it's not necessary to bring an umbrella. So don't bring an umbrella. Okay, so that's my program. Let's run it. Is it cloudy today? Yes. Is there a chance of rain? Yes. In that case, bring an umbrella. But with any other combination, if you look at the truth table, the answer is no. So is it cloudy today, but there is a chance of rain? No, yes. Still don't bring an umbrella. The only time we hit the body is if they're both yes. Okay? Any questions about this program? Mm-hmm. Yeah. So I need to make room for the user to type stuff. If I want to save whether or not it was cloudy and whether or not there was a chance of rain, I need variables for that. That's all. Because I want the user to type yes or no. I need to save those inside of a string variable. Any other questions? Yeah. This checks for equality. This gives back yes or no. Because we've already used cloudy equals yes to mean assign this value. Can't reuse that. We know how much of an issue that is now to put that in a condition. Good question. All right. So that's and. Let's talk about or now. Let's combine conditions with or. So here maybe are two other questions we could ask these. Is there a chance of rain? And is it currently raining outside when you look at the window? I think if either one of those is true, maybe, for our new program, then we should say bring an umbrella, right? If one's true or the other, or both. And so instead of two ampersands, it's two little pipe symbols. It's above the enter key. This means or. Okay? That's the idea. Is there a chance of rain, or is it currently raining? The truth table for or is kind of the opposite as for and. For and, it was very hard to make it true, right? In most cases, it was false. All other cases, it was false. For or, it's very hard to make it false, okay? So to test something like A or B, here's how you combine it with the two pipe characters. A or B is true. And A or B is true if both of them are true. Just one of the sides is true. Doesn't matter. It's true in any of those cases. As long as one of those conditions is true, or is like, yeah, I'm happy, it's true. The only way to make an or false is if both sides are false. Okay? Question? In later versions, current versions of C++, you can just type or like you can do in Python. But I want to get you accustomed to this symbol because there are certain languages that doesn't exist in. And this is the standard original version of it. Yeah, good question. You could just type or if you wanted to in C++. It'll highlight it and everything. It's relatively recent, that addition, though. All right, so that is, it's very easy to make it true. Just one of the sides got to be true. That makes it the whole thing true. Okay, and or is really nice for checking conditions that are like apart from each other. So like if you have certain numbers that you want to have happen, you want something cool to happen. If the user types a number that's between, here's my silly number line. If you want something to happen if the user types a number that's like small and positive, you can have a little condition for that. And then if you want the user to, if you want something cool to happen also, if the user types some small negative number, like you test for both of these cases, and then you OR them together. Like, did the user type this kind of number or this kind of number? And it kind of gives you both worlds at once. It's like this happened or this happened. It's the combined condition. Okay? That's what OR is good for. One thing or another, or both, if it's possible to have both. For these questions, it's possible to have both. Okay? Let me show you that. I'll call this what? Umbrella 2. So this time we're going to ask for, is there a chance of rain? And also, what should we ask? Is it currently raining? Chance of rain, comma, currently raining. Because I think you definitely need an umbrella in that case too. So if any of those are true, if chance of rain is equal to yes, or currently raining is equal to yes, in that case, you should bring an umbrella. Otherwise, I think we're good. Okay? And this is the or truth table, right? No matter what, as long as one side is true, the whole thing's true. The combined condition, the OR'd together condition. And we're doing umbrella 2. Umbrella 2. Is there a chance of rain? Yes, yes. Bring an umbrella. Yes, no. Bring an umbrella. No, yes. Bring an umbrella. As long as one side is true. The only way to make it false is if neither of these are true. Is chance of rain equal to yes? Or currently raining equal to yes? If I type no for both, then no, it's not true. None of them are true. So don't bring an umbrella. Okay, so that's or, kind of the opposite of and. Pretty similar to how we think about things like the word or in English. It translates pretty easily to this, yeah. Any questions about that? All right. I think I don't need to write code for this next one. It's just a quick one. There is a third option. It's called the exclamation point. It's called not. Oops, I accidentally typed something on my notes. This symbol, the exclamation point, I want you to read as not. I already kind of taught you to read it like that because of the relational operators up here, right? Where did they go? This is the not equal to operator. So you've already seen that in that context. We have decided that the exclamation point means not. So just read it like that. And what not does is negates your current value. So if you give true to not, you say not true becomes false. If you give false to not, it negates it. It's like makes false true. Not false is true. Okay? Because sometimes it's easier to think of something in the negative and check for something not happening rather than checking for something happening. Okay? It's easier to ask when something is false. Not will make it true, right? Rather than when something is true. So use not to, we call it negate a condition. And so, I guess, for example, maybe when you're thinking about the problem, maybe there's a problem where it's easier to ask the question like, is it not true that A is less than B? Like maybe that's an easier thing in your mind to grasp. You can just write something like that. Is it not true that A is less than B? And it will return true. It'll say yes if the answer was no for the less than operation. Does that make sense to us? It's kind of backwards. It flips things. Actually, not A less than B is equivalent to checking, at least for relational operators, if A is greater than or equal to B. That's the opposite condition. And let me prove that to you. Let's say A, B, I'll give you some options. A less than B, not A less than B, and then A greater than or equal to B. So let's try 40 and 42 for A and B, 42 and 40, and then 40 and 40. Okay, so is A less than B for 40 and 42? Yes. When A is 40 and B is 42? Sure, true. What about for this one, 42, 40? No, that's false. What about for 40 and 40? Also false. It's not strictly less than. 40 is not strictly less than 40. Yeah? And what about this one? Not A less than B. This is just you take this column, all of this, and you flip them. True becomes false, false becomes true. Is it not the case that A is less than B? No. True becomes false, right? The true gets flipped to false. The false gets flipped to true. Okay? Does that make sense? I'm flipping those conditions, what not means. And this is actually equivalent to checking if A is greater than or equal to B, because is A greater than or equal to B if A is 40 and B is 42? No, false. What if A is 42 and B is 40? Sure, true. What if A is 40 and B is 40? Yeah, then it's equal, true. So those are equivalent operations, but sometimes it's easier to think about the problem in the negated way. Okay, so that's what not is for, to negate your condition. Make what was false true now, to check if something didn't happen. Something like that. Are you good with that? All right, moving on. My computer sounds very unhappy right now, but that's okay. We got a lot going on. So the next thing that I want to talk about is precedence. This is something that I got a few questions about in this class already. I'm finally ready to show you the full answer. So one day, you're going to write a giant condition, or just make a giant arithmetic statement with a bunch of pluses, some timeses, some less than, some ampersands, some ors, some and some ors, right? And of course, PowerPoint won't let me press Control-Z and actually get rid of my writing unless I change the slide. So when you have a giant expression like that, you need to know how C++ is going to execute it, because some things need to happen before other things. It's the order of operations, right, for programming. We need that. How is it going to draw the parentheses? What's it going to do first? That's called precedence in computer science. Okay? Which operations precede others? That's the idea. So give you large things like 5 times 7 parentheses divided by 3 plus 4. What happens first? C++ knows about PEMDAS and all that. But then you bring in all this stuff, like A less than B and B less than C, or C mod D is equal to 42. Like, how in the world is this going to execute? Because some ways of drawing these parentheses might make it true, some other ways might make it false. So you need to know the default way. I need to teach that to you. Okay? So, yeah. In order of precedence, here's the rule that you're going to eventually memorize, and I need to explain it to you because it doesn't really make sense in words. In order of precedence, each operator, like an operator is a less than, an and, a plus, a times. Those are operators. In order of precedence, I'm going to tell you the precedence order. Each operator grabs the smallest thing it can to the left and right of it, and that's what it uses to perform its operation on. Okay? The smallest thing. I'm going to show you what that means with examples, though, because that doesn't really make a lot of sense. So here is the precedence table. Let me give that to you. Let me at least show it to you. How do I want to give it to you? I think I might have to give it to you on Discord right now or something. But I can at least open it up on my computer. Lectures, precedence table. I can at least show it to you. Actually, maybe I should have opened it here. That would be easier. Yeah, it's already having trouble anyway. Let's keep it. Here's the precedence table, okay? These are little groups of operators. There's a dot operator, plus plus, multiplication, division, remainder. They're in little groups. Here's and or down here. Here's high precedence stuff up top. Highest precedence done first. Lowest precedence done last. That's that. And what you do is you search this table for all of the operators that appear in your expression, and you find the highest precedence one, the one up to the top, the closest one to the top. Ones in the same group are in order from left to right. They have the same precedence level. And then they take the smallest thing to the left and to the right of them. So, all right, I'm ready with an example now. Here are my examples. Here is a big long string of operations. Let us consult the precedence table to see which ones happen first, which ones happen next. Okay? So here's the idea. We got to find all the operations on the table. So it's times, mod, and plus. Multiplication and remainder, same precedence level. So they happen from left to right in order. Okay? And then plus is below it in precedence. Remember, higher things get done first. So that means multiplication is happening first. It's at the same level as remainder, but it's to the left of it, right? Just like plus and minus in PEMDAS, like you do them from left to right as they appear. And then the third thing that happens is the plus, okay? So the multiplication happens first, and the rule is it's going to grab the smallest thing it can to the left and to the right of it. We're going to draw parentheses to demonstrate what's happening in what order, okay? So this multiplication can only grab the 5. That's the only thing to the left of it, so it's going to do that. And then what I mean when I say the smallest thing is that the times is not going to go way over here and try to multiply this whole thing by the 5. It's going to find the smallest thing, okay? It's not going to try this either. It's not going to try and grab this whole thing and multiply it by 5. The smallest thing it can grab is the 7. Do we see that? So that's what's going to happen first. The 5 times 7 will happen first in this expression. And then it's the modulus's turn. Again, it's going to grab the smallest thing it can to the left and to the right. I've already drawn parentheses, so I can't do this. The modulus can only take now this guy on the left. That's the smallest thing it can take, that whole expression. It's already been parenthesized. Does that make sense? Please yell at me if it does not. This is important. So, yeah, the modulus is going to take this. That's the smallest thing on the left of it. And this 3 by itself is the smallest thing on the right. Okay? And then the plus gets to go last. I don't have to draw any more parentheses. It's just going to get this whole thing and this whole thing. Yeah? Can't make anything smaller or bigger. Any questions about what I just did? It's like extended PEMDAS, essentially. Reading off the table. Let's do this fancier one. A less than B and B less than C, or C mod D equal 42. Are we ready? So let's consult the table. Let's find all of our operators. We got less than, there it is, less than, greater than. We have mod. That's up here. I think the mod's going to happen first. That's the highest precedence thing. It's up top. Then we have equality. That's actually below the non-equality relational operators. That's equal. Interesting. In a different group. And then we have and or remaining. Okay? So it looks like and happens before or. That's something I need you to remember as well. That's important too. So I think the highest precedence thing was the remainder. So we're going to do that first. This remainder is going to grab the smallest thing to the left and to the right of it. So it'll grab the C and the D. Does that make sense? It's not going to grab like the D equals 42. It's not going to grab the B less than C or C. It's going to grab the smallest thing, smallest unparenthesized thing, the C and the D. Okay? And then, all right, we're done with mod. Now we have less thans, equals, and ands and ors. So let's do the less thans. Those are the next ones. Okay? and they happen from left to right. So this less than is going to get parenthesized before this less than. So this is going to grab the smallest thing to the left and to the right of it, the A and the B. This is, again, going to grab the smallest thing to the left and to the right of it, the B and the C. Okay? And now we have equality that we still need to work on. What happens? So equality is now going to take the smallest thing to the left and to the right of it. It's not going to take this. It's not going to take this. It's going to take this, right? That's the smallest chunk that it can grab on the left side, and it can only take the 42 on the right. And finally, we have the and the or. The and is more important, has higher precedence than the or. So it's not going to be like this. It's going to be like this. Okay? Any questions about that? So it's going to, then finally, or together. I don't need to draw parentheses. It's going to or together this giant thing and this giant thing. That's the order. The and got parenthesized before the or. The and is more important. We say that and binds tighter than or. Okay? So, I would like to give you a question to try this with, and I need to give you the precedence table somehow. So let's try Discord if one of your group member wants to like look it up on their phone or something like that. Log in on the web version of Discord. I think that's the best place for me to put it right now. I'll give you the precedence table, and then I want you to try it on these expressions. Okay? I also want you to evaluate these expressions. So that's my goal for you now. Let me give you the table, though, when Discord decides to open. There it goes. Surely there are updates. Slowly but surely. Let's see here. Be fun. Come on, little Discord, you can do it. There we go. Precedence table. Drag. Enter. Processing. Okay, cool. So now you have the precedence table if you'd like to look at it. And here's my question for you. I'll give you like 3 minutes to discuss this as a group, and then we'll do it on by clicker. Boop. Go there, please. We'll do both of these in quick succession. So answer both questions, and then we'll talk about the first one first. So we'll do one, and then we'll do two. So here is your question. Do the following expressions evaluate to true or to false? So here is one expression that's completely unparenthesized. You're going to have to draw the parentheses, see how it's going to actually execute. Do it in your mind rather than code it up. That's a much better skill for you to learn, how to execute code in your head. And assume that x is 5 and b is true. So you can replace those with those values. So see what the answer is for true and for false. Or for this one. Is it going to be true or is it going to be false? And then finally this one. It's the same one, but I've drawn some extra parentheses, so you can't really change that anymore. Okay? And see if that one evaluates to true or to false. Okay? So, any questions about the question? What? Oh, yeah, use whatever you want. Write it down, type it up, and please help each other. So take about 3 minutes to try this. Try both of them, and see if there's a difference. And yell at me if you have questions. Do you remember what and or do? Remember the truth tables? About a minute and a half left. All right, that's my timer. Get our best guesses in. You'll get faster at this as you learn more. But let's try number 1. A or B, true or false? Did we get our answers in? So take another 10 seconds to do it. If you want to see what you're thinking in relation to what your peers are thinking, I'll give you till 4:35. All right. Oh man, are we not sure? So we think A might be the answer. So with the slight majority, we're thinking true. All right, let's try number 2. What do we think that answer is? I'll give you 20 seconds to get your responses in here. If you need to do a little extra work. Is there a difference? Was it the same? Like maybe it was the same. We're very confident about this one. That's interesting. Okay. Wow, we're thinking that B is false. But we really weren't sure about number 1. Interesting. Okay. Let's consult the precedence table. So how are we drawing parentheses around these guys? I can do it. Let me just do it really quickly. It's plus is going to happen first. It's going to look like this. Less than, and then this one, and then which one comes first, and or? And. We say that and binds tighter than or. And has higher precedence. So it's going to do this. For this one. This one I forced it to do the other thing, haven't I? So I was going to do this and check this and then or it with B and then and it with just x greater than 5. So you can change it by inserting your own parentheses. That's totally fine. Now let's figure out what's going to happen. So if x is 5, that makes this 6. Is 6 less than 8? Yeah, that's true, right? That part's true. And then I honestly don't even need to do this side, but let's do it for fun. Is x greater than 5? No, it's exactly 5. So this part's false. B is true. What's true ANDed with false? Is that true or false? Yeah, the false ruins the day. If one side is false, the whole thing's false. So true ORed with false, the final answer is true. Yeah? So technically, I didn't even need to. Once I noticed that the left side of the OR was true, the whole answer was true. As long as one side's true, the whole thing's true. Actually, C++ doesn't even worry about this side if the left side's true, which can lead to interesting execution strategies. So the first one is true. Good job if you got that one. We weren't really sure though, but that's exactly what's going to happen. And then this one is going to check the same kind of thing. This is again going to be true. It's going to OR it with true, right? This whole thing now is true. And it's going to AND it with something that's false, though. Oh no. That's going to bring everybody down, right? AND with false, the result is false. So it is true and false. Any questions about that? For OR, I'm talking about OR versus AND. For OR, as long as one side is true, whole thing's true. For AND, they both need to be true for the final thing to be true. One false brings you down. It's kind of They're called duals in that sense. There's a very strong mathematical relationship between and or. All right, so that's the reason why you probably should specify, do I want the and to happen first or do I want the or to happen first? Because if you forget and you want the other way, it's going to do the wrong thing. This is going to be a bug. It's going to be a logic error in your program. Right? You want one way but end up getting the other because of precedence rules. Okay? So now you understand this expression. This does not work, and precedence tells you why. You cannot in C++ check this and have it be like, if x is 3 or 4. Because it's going to draw the precedence rules this way. It's going to check, is this true or is 4 true? And 4 is always true because it's a non-zero number, so it's always going to be true. Does that make sense? If you want to check whether or not a number is 1 or another, it's got to be like this. If x is 3 or x is 4. Does that make sense? The precedence rules tell you the truth here. This is not going to do anything useful. It's a very common error, but now you can avoid it. Okay. Are we ready for some fancy examples that combine everything we've learned? So that's where I'm going. Okay. The first problem is called FizzBuzz. It's a very ancient programming exercise. They used to give this question in programming interviews to make sure you knew how to program. It's so easy nowadays because everybody teaches it that they don't ask about it anymore, but it used to be a thing. It's called FizzBuzz, and here's the game. All right, so the user inputs a number n, and then you're supposed to print something, something else, or a fourth thing, depending on the number that the user gives you. So you're going to print fizz if that number that you were given is divisible by 3. You're going to print buzz if the number is divisible by 5, and you will print FizzBuzz if the number is divisible by both 3 and 5. If none of those are true, it's not divisible by 3 or by 5, then just print the number out. So if the user types 1, you print 1. If the user types 2, you print 2. If the user types 3, that's divisible by 3, so you print fizz. 4, nothing, just print 4. 5, divisible by 5, of course, so you print buzz. 6 and 9, they're all multiples of 3, so they're divisible by 3, but not 5, so you print fizz. 10 is buzz, multiple of 5 only. And then finally you get to 15, 30, 45, those kinds of things. That number is divisible by both 3 and by 5. So you print FizzBuzz if the user gives you that one. Does the game make sense? Now I need to teach you how to program it. So you need to be able to check for divisibility by a certain number. And I've already taught you how to do that for divisibility by 2, because that is even and oddness checking, is it not? This condition returns true if the number is even, because we're checking, hey, divide n by 2, is there nothing left over? Does this number n go cleanly into 2? That checks for divisibility by 2. Does that make sense? There's nothing left over, that means it was divisible by 2. It also checks for evenness, because that's another English word we have for divisible by 2. So following that pattern, here's how you can come up with the condition for divisible by 3. That's such a hard word for me to say, apparently. Do mod 3, get the remainder after dividing that number by 3. If there's nothing left over, it went in cleanly. So it was divisible by 3. Same for 5, same for 15. Yeah? Does that make sense? So that is the game, and now I need to implement it for you. Here, I did it. There's something wrong with this, unfortunately. It's following my pattern, though. It's like, all right, if n of it's divisible by 3, print fizz. I don't think I can use blue right now. It doesn't mesh well. So like, yeah, if n is divisible by 3, print fizz, sure. If n is divisible by 5, print buzz, sure. Else if, right? That's kind of following our rules. Else if n is divisible by 3 and it's divisible by 5, that's a correct and, right? Then print FizzBuzz. Otherwise, print n. This doesn't work. Tell me why. See if you can figure it out. So go to the Written Ice page, help each other, see if you can convince each other that it is wrong, and see if you can figure out why. Did I clean this out already? Looks like I did. So I'll give you I don't know, maybe just 2 minutes to try this one out. It's either you see it or you don't kind of thing. It's okay if you don't see it. I'm going to show you exactly what's wrong here. But see if you can find the error. Why is this not following the game? Why is it not printing fizz buzz, and or the number properly? The conditions seem right, but the output is wrong sometimes. So think about that. See if you can write down the reason. Another minute or so. All right, let's see if we figured it out. It's divisible by 3 or 5. It will take those pathways and never reach the necessary pathway. Yeah, there's an issue if it's both divisible by 3 and divisible by 5. I think a few of us have discovered that. So great job noticing that. If it's divisible by 3, then it exits out and prints just fizz. So there's an ordering issue here. Let me show that to you if we didn't see it. I'll code it up now. So, I don't know. Enter a number. If n mod 3 is equal to 0, then cout fizz. Else, if n mod 5 is 0, then cout buzz. Else, if this one will be fizz buzz, and then else it's just a number. Alright, so this condition is the combined condition, so if, oops, go back. If n mod 3 is 0 and n mod 5 is 0, then print fizz buzz. This is actually similar to the ordering issue for the grade calculator question that I gave you before. It's got to be the hardest thing to do needs to happen first. The least general thing, because otherwise more general conditions will become true sooner than you want them to be true. So let's run this. And it works for most numbers, like 1, 2, 3 is fizz, even 6 is fizz. 5 is buzz, 10 is buzz, but 15 should be fizz buzz, and it prints fizz right now. And the issue is 15 divisible by 3? That's the first thing this if statement checks. Sure is, it's divisible by both 3 and 5. So it never even gets here. Do you see that? It never even gets there. It finds the first true case and it's done. Let me draw that for you. So we check this first thing first. N mod 3 equals 0. That's the first thing the if statement, this big long if else checks. It checks its first condition. It asks the question, is n divisible by 3? Question mark. If the answer is true, then it immediately prints fizz. If the answer is false, then it tries some other condition. Then it goes to the else if. It tries this condition. And it asks the question, is n divisible by 5? Question mark. If that's true, then it prints buzz and is done with the whole thing. Otherwise, if that's not true, then it checks the final condition, is n, this one, divisible by both 3 and 5. If that's true, it prints fizzbuzz. Otherwise, it prints just the number n. Okay? And so the issue was n was 15 or 30 or some other number that's a multiple of both 3 and 5. And we checked this thing first. Is 15 divisible by 3? The answer is, of course, yes. Because it's also divisible by 5. So we printed fizz, and we were done with the whole thing. Okay? Do you see the problem? So in order to fix this, we better have the hardest thing to do, the thing that some of these cover already, better be the first thing we ever check. This better be the very first thing we check, because it's covered by the other conditions already. We want the least general thing first. More generic things second. Okay? So we just got to change this order. Boop. 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 This one will be fizz. This one will be fizz buzz. These orders don't really matter, but let's get them back to how they were. There. This better be the first thing you check. Okay? And now we'll be happy. 15, fizz buzz. 30, fizz buzz. Anything else? 33. It all works. Okay? Any questions about this? It's an ordering issue. Because if else's, they always check to find the first condition that's true. Then they run its body and they're done with the whole darn thing. Okay? Are we happy with this first example? So I have more. That's fizzbuzz. Let me talk to you about string comparisons, because this is a weird thing. So strings, if you make a string, and you try to compare that string with another string, like do the less than operation, it's going to compare it using what's called lexicographic ordering, okay? Which I believe is a Greek word, and that just means dictionary. Dictionary order, okay? So if you give the string ABC to C++, and then you give the string BCD to C++, and you ask, is one less than the other? The answer is true, because it's going to compare them like, would this come before this one in the dictionary? The answer is, of course, yes, because the A is smaller than the B. Yeah. For similar reasons, A, B is less than, as far as C++ is concerned, A, B, C. That'll be true. Okay. Dictionary order. But it gets really weird because there's ASCII stuff involved. It's really comparing ASCII codes in order. So lowercase my name is going to be less than, or actually greater than, no, because yeah, the lowercase numbers are above the capital numbers. That's going to be greater than my capital name. So you just got to watch out for that. If you want to compare things, maybe you should make it all lowercase or make it all uppercase. Similarly, the digits come before the lowercase characters. So 0 is less than A, the string. So you just have to think about the order of things. That's pretty much it. So, yeah. That's comparisons, and let me also show you a couple fun demos with the library. So let's see here. Demo number 1, let's capitalize a word that the user enters. So we'll convert it to a proper noun. So if I type my name, it will capitalize the first character of my name. Okay? And we're going to use CC type. C++ CC type. That's a library that we haven't seen yet. CC type has a bunch of character functions. These functions test if something's a certain kind of character, like this isDigit function takes a character and returns true or false whether or not that digit was a digit or not, or whether that character was a digit character or not. For very weird reasons, it says it takes an integer and returns an integer, but think of it as taking a character and returning a bool. That's the C library for you. So those are those kind of things. Is it an alphabetic character? Is it an alphanumeric character? Those are useful. Probably even more useful to us are these toLower and toUpper functions. toLower takes any character and returns back a character, not an int. You can think of it like that, though. And returns back the lowercase version of that character. So if you give it any capital letter, it's going to translate it to the lowercase version of that character. Or if you give it some other character that isn't a capital character, it's just not going to touch it. Give you back the same one. So toLower and toUpper will be our friends here. Okay. So yeah, demo. Convert a string to a proper noun. Boop. Where do I want to be? I want to be here. Strings.cpp. So I need the string library if I want to have string variables, and I need CC type if I want to capitalize something. toUpper. So string s, I don't know. See out, enter a word, and then cn is nice. It gets a single word. Cn into s, please. And yeah, we want to capitalize the first character of it. Okay. Create a proper noun. So what needs to happen is if I type my name, or I type any word, here's my string s. That's like A, B, C, D. My job is to go here, index 0, make it capital A. Yeah, that's how you make it a proper noun. So let me show you that one. Boop. So we need to go and change s at what index? What's the first index? Did I write it? It's index 0, right? S at 0 is whatever it was, but capitalized. So toUpper. Okay, and now it's been capitalized. So I just print it out. So now s has been changed. Character at index 0. If it wasn't capital before, now it is. We enter a word, my name all lowercase, and it capitalizes it. ASDF capitalizes it. BCD capitalizes it. Just the first character. If it's already capitalized, or if it's like a number, it doesn't touch it. toUpper doesn't touch anything that's not a lowercase character. Just keeps it. Gives back the same character. Okay. And any questions about this code? It's just a new library function. My second example is more interesting. Let's check if a string ends with a number. So let's say these are typed ABC, I don't know, or AB12 or something. I don't know. Instead of CD, maybe they typed a number at the end. I need an eraser though, please. ABC5. We need to check if this is a digit, right? If the last character in our string is a digit. And we have a function for that. It returns true or false based on whether or not that character was a digit. So we'll call isDigit, and we need to give it the last character of our string. The issue now is, how can we find the last character? Because the user might type a very long string, or they might type a very short string. How can I know that no matter what string it is, how can I figure out what this index is always? Do you have any ideas about that?
Is that 4?
What?
4?
4? This one, yeah. This one will be 3. Yes.
Oh, okay.
That's the last index for that one. But what if these are typed, what I'm trying to say is, what if these are typed hello 5? Now the index is 0, 1, 2, 3, 4, 5. No, that's the last index. How can I always know where the last index is? What can I use? How can I calculate 5 from this string? How can I calculate 3 from this string? What do I have at my disposal? There is a library function that will work for this, yes. But which one? It's actually not on this page. No, none of these are counting anything. They can't tell you where the end of a string is. We need to be able to figure out this last index. What is this? How can we always find it, no matter how long the string is? I kind of heard it, maybe. Well, no, we need a number. We don't need true or false. Yeah, it's size. You can always ask for the size of the string, can't you? S.size. That will tell you how many characters are in that string, yes? So this one will give back 4, but I wanted 3. If my string was hello 5, oops, if I can spell, the size of this string is 1, 2, 3, 4, 5, and it'll give back that. No, sorry, 1, 2, 3, 4, 5, 6. This will give back 6, and I wanted index 5. So I wanted 5 from 6 and 3 from 4. What can I do to the size to get the last index? It's always minus 1. Because it starts at 0, you just got to subtract 1. That's the game you got to play. So no matter how big this string is, it's always s.size minus 1. Let's write it up here. Boop. That's that index. No matter how big the string is. Does that make sense to us? That's the last index. So check if the string ends with a number. If s at s.size minus 1 is a digit, so wrap this in a call to isDigit. This gets ugly, but I think you've understood everything I said, right? If isDigit s at s size minus 1, I kind of did it from the inside out. That makes more sense to me. In that case, yeah, we found a digit in that order, in that place. See out s ends with a digit, with a number. Else, see out s does not end with a number. Okay. So, if I type my name, it does not end with a number. Type my name 42, it ends with a number. ABC 4, S ends with a number. Doesn't matter, it can always find that last index using this calculation. Okay, let me check if it's a digit. Returns true or false. Any questions about that? That's pretty cool. All right, let's keep on trucking if we're doing okay. The next thing I want to show you is comparing when you're comparing doubles, okay? So here's a dumb idea. Let's take 0.1 and add it to itself 10 times. What should the answer be? Should be 1.0. I want to call this. I'll just call it doubles. Yeah. So, okay, double D equals 0.0. D equals itself plus 0.1. A faster way to do that is to say D plus equals 0.1. So let's do that 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. See out. I need manip. Fixed set precision of 16, as much as it can do. D. Okay. That's not 1.0. The way that doubles are stored is not a normal way. You'll have to wait until CSCI 45 to learn that. But it is a weird encoding. It's a binary encoding. So 0.1 is actually not like immediately representable in its binary double encoding. And so it's a bit rounded off. It's not precise. It's precise to a certain number of decimal places, but we're asking for full precision right now. And we're not getting it. So it would be wrong to ask of your doubles if D is equal to 1.0, do something. This is a horrible idea because doubles usually aren't ever exactly equal to what you want because they're going to be off by some small rounding errors that just are part of the way that doubles are stored in memory. Okay? So let's comment that out. We never want to do that. Okay? Does it make sense why you never want to check for exact equality on a double right now? It's never going to be what you want, usually. It's really going to be 0.9999 instead of 1.0 that you thought you got. Okay? So, yeah. I checked. Is there a question first? Yeah.
Is that going to be the case for, like, you just did it 2 times, and then you're checking 0.2? Or is it only, like,
The precision gets lost over time with more uses with more additions and things, but honestly, it might not even get to 0.2. I can't remember. You can try it. So yeah, I checked this, and that's a horrible idea. Okay, so some information when you're storing doubles, it's only correct to a certain number of decimal places. Some info gets lost. There's only so much precision. We trade precision for a large number of different numbers that we can store inside of a double. Okay, so you should never be checking for equality. Instead, if you have doubles and you want to check something about them, you just check that they're really close to each other. Okay, really close to what you wanted it to be. Like here's your number line. You wanted the number to be 1.0, but it could have been maybe somewhere between like, I don't know, 0.999 and 1.001, something like that. Some very small range is what you really want to check. Check if the number is between here and here, because then you'll get what you're looking for. It's close enough. Does that make sense? That's what you need to check. Check for a range. Okay. And the way you do that is with the absolute value function. To check if a number is over here, within 0.001 of a number, then you check it like this. You say, hey, is my number D subtracted from 1.0? The absolute value of that is the distance. This is like a distance formula. Is the distance between D and 1.0 super small? Does that make sense? And the reason you use absolute value is because you're not sure which side it's on, so it could be a negative result or a positive result if you don't do the absolute value. But this will make it positive, and you can check, is the result very, very small? Is the distance between D and 1.0 tiny? Yeah, I'm about to do that. That's what we need to check, okay? And where is absolute value? It's in CMath. Or actually, no, it's in C-STDLib, isn't it? It might be here. Aha, is an abs. Or you know what, this is integer abs, sorry. Excuse me. CMath has the floating point abs. And that's what confused me. CMath. We would like to use, where is it? F-abs. Absolute value of a floating point number. Takes a double, returns the absolute value of a double. Okay. So, instead, we do it like this. You say, instead of C out, like, is D equal to 1.0, which is going to be false. This will print 0 because of the way C++ prints numbers. Oops. So that'll print 0 for false. Instead, we check, hey, is the absolute value, f-abs, of D minus 1.0, is that very small? Is that less than 0.001 or something? Okay? You can use some pretty good precision, 0.00001. That's still fine. And I need to include CMath to obtain that function. Okay? So, f-abs, the number minus something, is that distance very small? That is going to be true. And that's how you need to compare your doubles. Okay? There's my one. Any last questions about that? All right. I have 2 more examples. Grade calculator. So now let's do the real thing. So given a grade as a percentage, let's print A, B, C, D, or F. Okay? Grade, let's say it was like, I don't know, 85.5. That should be calculated as a B. All right? So I will slowly type. I'll give you like a head start. How about you guys try this as a group? And after a minute, I'll start typing it myself. But see how far you can get. See if you can remember the ranges and the proper orders of conditions. How can you remember what we were doing last time? You can get away with just checking one end of the range as long as it's in the proper order. Using the else ifs. And honestly, maybe I should be saying 90 to infinity. Extra credit is a thing. Should be the same result anyway. Alright, so hopefully you've had an idea in your mind, even if you haven't been able to type it out completely. Let me show you how I'll do it. Just grade.cpp. So let's ask the user, can I just steal some of this? Boop, boop. Enter a grade as a double. CN grade. And now we're going to check it. So if it's an A, we can check that first. Anything greater than or equal to a 90 is an A, right? If grade greater than or equal to 90.0, then see out A. And now the beauty of else if is I can just say else if grade greater than or equal to 80.0. And this will grab the B range, won't it? Because if we got here, we know that it wasn't greater than or equal to 90. So it must be, the opposite of that is it's smaller than 90. Strictly smaller than 90. 89.99999 on forever, downwards. So if that's true, and this is also true, there's kind of an implicit and going on by the fact that we didn't hit this case, it's false. If we're also greater than or equal to 80, we know we're within the B range. Does that make sense? That gives us this condition just by having gone down and passed the first check. This wasn't true and this is true. That means we're between 80 and 90, not including 90. Okay? Because that's the trick. That's how we get home free after that. Else if grade greater than or equal to 70, do another thing. Let's just boop, boop. 70, 60, and then just do an else there, can't we? C, D, yeah. And then this one's going to be an F, and we can just make this one else because if we fall through this far, if you think about it long enough, like it wasn't great, it's strictly smaller than 90 if we didn't hit this one, it's strictly smaller than 80 if we didn't hit this one, all the way down to it must be smaller than 60 if we didn't hit this last case for the D. Okay, in that case, it is lower than 60, it's an F. Okay? Does that idea make sense? That's the proper order. Not as necessary. You can't check for D first, D before A, because it's easier to make a D, right? Greater than or equal to 60, sure, that's true of 90 as well. So you better make the hardest thing the first condition. The hardest thing to make happen. The least general thing. Sorry, not doubles, but grade. Enter a grade, 95, A, 85, B, exactly 70. I don't know, 67, 55, it's all going to work. Okay? Any questions about this ordering, why it's the right order? You could get away with checking for ranges if you really wanted to order this in a different way. You could make B come first as long as you check, like, if grade is greater than or equal to 80 and grade is strictly smaller than 90. That will allow you to, like, separate into distinct chunks those ranges, but I think this is easier. Alright, that is my second to last example, at least in terms of code. One more code example. Let's make the beginnings of a guess the number game. Okay, so we're going to generate a random number between 1 and 100, and we're going to ask the user if the number that they entered, or we're going to ask the user for their first guess, right? And we'll tell them each time they guess if it was too high, too low, or just right. If they got it, we'll tell them congratulations. Otherwise, we'd like them to guess again, right? So let's get that started. So let's call this guess.cp. It's a fun little game though. So I need randomness. So I need cstdlib, and I need to seed my random number generator. So I need ctime as well. srand time 0. So it's a different game each time, right? And then so let's seed the random number generator. And then I need to make a random number between 1 and 100 and not tell the user. It's their job to guess it, right? So int, here's my random number. N is, we call rand. I can do rand mod 100 to get a random number between 0 and 99, but I want it to be between 1 and 100, so I'll add 1. And precedence rules tell you why I don't have to draw any parentheses around this. And then I'm going to ask the user for a guess. So I'll make room for the next guess that the user types as well. Okay? So here's the process. Ask the user for a guess and see if it was correct. Okay? That is going to be our job. So, okay, see out. Enter your guess. And then we're going to put it into the guess variable. And then we're going to check, hey, was the guess smaller than the secret number? If so, we better tell the user, give them a hint, like, no, you guessed too low, right? Your guess was smaller than the number I'm thinking of, so too low. Else, if the guess was too high, right? It was bigger than the number, the secret number I'm thinking of. You tell the user, give them a hint, too high. Else, what is this case? If none of the above were true, yes. Then it must be equals. If it wasn't strictly smaller and it wasn't strictly greater, the only other option is they got it. You got it. Exclamation point, exclamation point. New line. Okay? So, that's that. This isn't the greatest game right now because, enter your guess, 42. Too high. Program's over. You only get one guess right now, don't you? Enter guess 50 is like the best possible first guess, but too low, and it was a new guess every time, or a new number every time we ran the program, so we better ask the user a few times, right? So we want our program to continue as long as the user hasn't gotten it wrong yet. So I'm gonna have to just copy and paste everything a million times, sadly. There's a way to fix this. That's gonna be the next set of slides. But right now, all that we can do is just copy and paste this code to have another guess opportunity. And because the user might get it in the first guess, here's my rationale. The user might get it in the first guess if they're super lucky. If they do, we don't want to continue asking them for the next guess, right? That would be silly. We should stop the program once they get it right. So here's what I'll do. If they get it right, don't ask for another guess. Let's just tell the program to end itself. And that is in cstdlib. You can also just return 0. That also works. But there's a cstdlib function. There it is. Called exit. That also works. So terminate program. You say exit with whatever return code you want to give. So I'll say exit 0. Exit 0. Stop the program. And so if they get it right, we won't just come back and ask them for a new guess because they already got it. Okay, so let's copy and paste this code a million times. And this is just going to look super ugly. This is going to motivate us to do something better. So now there's four guess opportunities. Now there's 8, 12, oops, oh gosh, of course. Now there's 16, if I duplicate that again, I don't know, let's have 32 guess opportunities. That's the max number. The user's not good enough if it gets to the end of the program now. They're doing it wrong. So there's about 400 lines in this program, and it's the same thing a bunch of times. It's just these lines all over again. But that'll make a guess the number game, right? So it'll just keep on running this code one after another. We had to copy and paste it. So /guess. And now let's play. So guess of 50, too high. Okay, that means the number was smaller. The secret number must have been smaller. So 25. Too low. Ooh, we're getting there. I don't know, 35. Too high. 30. Too low. 31. 32. Yay. Isn't that beautiful? It was also a perfect power of 2 the first time. That's pretty beautiful. So, all right, you can keep playing this game. 50, too high, 25, 35, 45, 40, 39. Definitely try this out because it's a fun little game that you can understand completely now. So the number was 37 this time. It's still possible to lose this game, isn't it? Because I have 32 opportunities to guess. If you just keep on guessing 1 32 times. Oh, okay. Game ends. So it would be nice to just continue as long as the user gets it wrong. There's a way to do that, and we'll get into that next time. But that's our Guess the Number game. Are there any questions about it? So yeah. We had our number, we had our guess. We're always comparing our secret number, whatever it was, 32, with our current guess. Maybe that was 50. Okay, we'll keep on updating guess. All right, so are we good with that one? All right, so last example is not code. This is something I'd like to get you good at. Just running code in your mind. That's going to be the best thing for you to learn at this point in your computer science career. To not have to code something up to see how it's going to run, to understand exactly, at like a visceral level, exactly what this code is going to do. Okay? So let me show you, let me walk you through how I think about this. Okay? This is a bunch of code, a bunch of lines of code. Like this is the first line. This is a giant if-else, this whole darn thing. And then J is one last line. So here's how this is going to run. Here's how I think about it. A happens first, then we run the if-else. Okay? Just one big thing. So to run an if-else, you better check the condition first. That's the very first thing that happens. You say B question mark. If it's true, we do the body, we do the C, right? And if that is all well and good, we have then completed everything. The entire if-else is done because it only goes down one branch. We went down the shorter true branch. So now the whole if-else is complete if we went down the true branch. Now we jump down to J. Whee. That's the last thing that always happens, J. Okay? If it was false, now we're in the else case. We have another if-else, if-else. Beautiful. So to run that, we check the condition first. And then I is always the last thing that happens after that. Whee. I don't want that anymore. So it's D. D question mark. If D is true, then we do E. We run E, and that's the entirety of the if-else, if-else, isn't it? So I've just completed this whole thing. I still have I to run. So then we go to I, and that completes the inner else for that particular branch. So then we're done with the whole if-else, and we're down to J. I'm doing that. If D was false, then I better check F, because we might hit this case or the else case, depending on the outcome. So F question mark. If F is true, then we're going to run the else if body, that's G. And then we're done with the whole if-else, if-else, but we need to go to I after that. So I. And then if that was false, then we hit the else case, that's the H. And then again, we're done with the whole if-else, if-else. We go to I, which then goes to J. That is how I think about that. Did you catch that? That takes practice. It really does. So I promise you'll get good at it. And one way to get good at it is to use this resource. It's called C++ Tutor. You can just search for this on Google, and It's part of a website that was originally made for Python, so it's called pythontutor.com/cpp.html, and it's called C++ Tutor. And here's what you can do. Let's take our grade calculator program and copy and paste that in. The one thing about this, the one downside of this website is you cannot ask the user for input. CN doesn't work. Here it is. It takes you to this page where you can type in code. I'll just replace it with my guess the number game, or not guess the number, grade calculator thing. So CN is the one thing that doesn't work for this. So you have to hard code your values. Just like pretend the user typed grade as like, I don't know, 75.5. Yeah. And then you can type visualize, or you can click visualize execution. And this is the most beautiful thing you have ever seen for this point in your computer science career. It starts the program, tells you where it is right now, puts a little arrow. It's like, I'm about to run this line. I have made box in memory that is a double for grade, and I need to give it a value. That's what this line does. So I can click next. Boop. Now it has a value 75.5. You can watch this program execute. And you can change the value later. You can set grade to something else, see how it changes the execution order. And it will do exactly what I kind of did in my head. It'll teach you how to get this. Okay? It'll check the condition. Is the grade greater than or equal to 90? No, it's not. So it better check the other condition. That's the next thing it does, right? That's the next step in this particular case. Is grade greater than or equal to 80? No. Okay, let's try this other condition. Is grade greater than or equal to 70? Next. Ooh, it was. We hit the body. So we're going to output C. And it shows you the output up here. Very tiny. And then that's the entire if-else, if-else. So it returns 0. That's the end of the program. And you can watch the values change. The only thing you have to do is hard code the values. You can't use CN because it's trying to run the whole thing for you and show you the execution. You can't pause and ask for input. That's the one downside, but I think that's beautiful, don't you? Very, very helpful. So if you're ever concerned or confused about how your program is running, put it into this. Okay? And with that, that is everything that I had for the day. Are there any last questions that you'd like to get recorded? All right.